All right, so let's get started.
All right, let's dive in. We're designing a URL shortener system. Think something like bit.ly or tinyURL. We'll take a long URL and generate a short, unique alias that redirects to the original link. Now, I want you to start by defining the functional and non-functional requirements. Once you've laid out those requirements, we'll go from there.
All right, so I think let's start with functional requirements. So we'll want to create the URLs first of all. So create the short URL from original long URL. And then we'd also want to redirect. So redirect short URL to long URL.
Good. That's a solid start. We've got two core functional requirements: creating a short URL from a long URL and redirecting from the short URL to the original long URL. Now go ahead and add those to the whiteboard. Once that's done, let's move on to other requirements you think we need.
So also I have a question. I'm thinking we could also use analytics here just to see like the actual data for these short URLs if we want to give that to the end user. So I'm thinking also one of them could be collecting analytics for the short URLs.
Yes, collecting analytics for the short URLs is a great addition. That should include tracking things like the number of clicks, timestamps, maybe even geographic data. So go ahead and add that as a third functional requirement. Then let's continue.
All right, now let's talk about non-functional. So we'll have 100,000 new URLs per day, maybe. I think that could be something we could consider, or we could do more, like 200,000. I'm not exactly sure how many new URLs are in Bitly or tinyURL, but what do you think about that?
Let's lock that down. We should pick a concrete number. Let's go with 100,000 new URLs per day as a baseline. That's a reasonable starting point for scale. You can always adjust later if needed. Now let's add more non-functional requirements, like latency or availability.
Okay, now continuing on scale, I think if we could have maybe 1,000 redirects per second for the peak, so redirects. Do you think that would be good for the system? I think that would be simply because at a given moment, 1,000 is a lot, but we need to go up to that potential because there could be certain events that are held with short URLs because they don't want people to put the full long URL in. So I think we need to have a high redirect ability.
Yes, a peak of 1,000 redirects per second is a solid target. That gives us room for those high traffic events and ensures the system can handle significant spikes. Go ahead and add that as a non-functional requirement. Then we can continue refining availability and latency next.
All right, so now latency, I think we should focus on having it really low. So again, if we don't have low latency, our the purpose of the URL shortening service will kind of be negated because we need to have that latency be so minimal that it's practically negligible to an original URL. And if we're able to do that, then it's great. If we're not able to do that, then people just won't use the short URL service.
Exactly. The latency has to be extremely low for redirects, ideally in just a few milliseconds, so the user doesn't even notice a delay. Go ahead and add a non-functional requirement for low latency redirects. Let's say under 10 milliseconds. That keeps the user experience seamless.
All right, so now the next step, obviously, high availability. So I'm thinking high availability because we need to have a lot of, we're going to have a lot of URLs, and this is much of the uh, cap theorem that is involved here, the consistency and availability. Because even if we're not always giving the URL like a minute after it's been published, if we have that availability, then that would be much more important because we need to make sure that all the URLs are accessible without fail. Because if something like that were to happen, this could significantly impact our business.
Absolutely. High availability is crucial. We need to ensure that the short URLs are always accessible, even if there's a slight delay in propagating a newly created one. Let's aim for something like 99.99% availability or higher. That ensures users can always reach their destination. Go ahead and add that high availability target to the non-functional requirements.
All right, so now I think we should focus just a quick little note for the API endpoints. So what I'm thinking is it's pretty simple. We'll have the post and the get, which is the main one for the actual URL. So we'll have API endpoints, and then let's just say we have a post, and then let's just say the endpoint is shortened. So basically, we'll send in the body of the original URL, and then we'll basically from that we'll have the actual shortened URL that is returned, and then for the get, which is for redirects, we'll just have slash and then just the short URL, and then again that's just to redirect.
That's exactly right. The API structure is simple and effective. A post endpoint like shorten to create the short URL, and a get with just the short URL path for the redirect. That covers the core functionality. Now that we've got that noted, let's continue with any additional details, or move into the architecture now.
All right, so I'm thinking also just real quick before we go into the architecture to specify some encoding. So one encoding that would be good, I think, for this scenario would be the base 64. Or sorry, base 62. Yeah, base 62 encoding because it has a lot of potential. You can go from 0 to 9 for your digits. You can go from uppercase A to Z, and then also lowercase a to Z. And this reduces the amount of collision risk that we have because much, we'll have just a larger potential number of URLs, so we have low risk for that.
Good. Base 62 encoding is a smart choice here. It gives us a large character set, digits, uppercase, and lowercase letters, which reduces the length of the short URLs and minimizes collision risk. It's efficient and compact. Great call. That encoding approach will be key when we move into how we generate and store these shortcodes.
Okay, so now let's just say we have, let's just start off with the user. So we'll have the client, right? And let's just have some simple load balancing. I'll just put a placeholder here for now. We'll just have the API load balancer from all the traffic from the client. And then from there, we'll actually reach the API gateway. So I'm thinking we'll have two separate paths that they can take. So from the API gateway, we will have the path of let's just say redirect. So I'm just going to put a redirect load balancer here again. That's going to, because redirects, I feel as if that would have more of a need for load balancing than the, the shortening, like creating the URL itself. So just as another barrier, if this load balancer wasn't able to handle that as much.
Good approach. You've identified that the redirect path will likely have a much higher volume and needs more dedicated load balancing. So splitting the API gateway into separate paths, one for redirection with its own load balancer, and another for the URL creation flow, makes perfect sense. That structure will help handle the different load characteristics. Now, let's build on that and continue with what components come next in each path.
Okay, and then I'm just going to put like a redirect service right here just to indicate that that's where the server is at. And then for the actual place where the URLs are coming from, I think we should definitely cache. So caching something like Redis or memcached would work well here. And this basically would allow the top URLs not to be fetched every single time. So I'll have this kind of connection right here that goes both ways. And that'll be a very crucial part. Okay. And then now also, again, we're going to have the other end of the spectrum. So I'm just going to move this over a little bit. Now let's actually add the shortening. So what I'm thinking now is we'll just have a service. We'll just call it shortening service. And this is the server that's actually doing the work behind shortening. And actually, speaking of which, we're going to have some kind of database. I should probably introduce it now. So let's just call this the user, or not the user, the URL mapping DB. Basically, this will just have all the long URLs and short URLs. So I'll just connect that to the cache again so that it's always, the latest are always there. And the shortening server should also connect to this to update this with the post request.
That's solid. You've got the shortening service connecting to the URL mapping database to store the long and short URL pairs, and the cache right in between to handle the hottest data. That ensures the most frequently accessed URLs are served quickly, and the shortening service keeps the database up to date. This structure looks good. Let's continue fleshing out any remaining components or details.
All right, so from here, let's see. We'll have to have some kind of, okay, we already have caching. And oh yeah, I'll just connect this API gateway down to the shortening server. And that'll basically be a good chunk of the actual high architecture. So user authentication is out of scope for this interview, correct?
Yes, user authentication is out of scope for this interview. We're focusing purely on the URL shortening and redirect architecture. What you've laid out so far covers the main components: client, API gateway, load balancing, the redirect service, caching layer, the shortening service, and the URL mapping database. This gives a clear foundation. Now we can dive deeper into any particular area you want to expand.
Okay, I'm just also gonna add some. Okay, so first of all, we're definitely gonna need to shard this URL mapping database, and I say this because we just have so many URLs, 100,000 new URLs every day. That's just going to stack up way too much if we were to vertically scale that. So we definitely need to approach it with a horizontally scaling mindset. So I'm just gonna show how we could do that. So just a couple of DB shards here.
Good call. Sharding the URL mapping database is essential at that scale. With 100,000 new URLs per day, horizontal scaling through sharding will help distribute the load and keep performance high. Each shard can handle a portion of the data, and that ensures we can scale out as the system grows. Now that you've added those shards, the architecture is looking more robust. You're on the right track.
All right. Okay, let me just fix this real quick. So, all right, we'll just have that there. So now let's just consider some scalability. Again, we'll have the load balancing and we'll have a double layer here. I'm assuming this API load balancer again is going to be the first line of defense against some high request and demand just straight off the bat. And from there, we'll also need another load balancing system and the redirect service because the shortening service itself shouldn't need a load balancer as badly as the redirects because most people who are going to our application are going to be redirecting. Does that sound right?
Yes, that sounds exactly right. The redirect path will handle far more traffic than the shortening path. So having that additional load balancer in front of the redirect service is crucial for scalability. The shortening service, on the other hand, will see fewer requests and doesn't need the same level of load balancing. So having that double layer approach with the API load balancer first, and then a separate load balancer specifically for the redirect service, makes perfect sense. That's a very scalable design.
Okay, one quick thing. I think I forgot to mention this, but I'm just going to add it. The database schema itself, we're just going to have the short URL, the original URL. I'm assuming the creation date, and then we'll just have an expiration date as well, just because we don't want to keep these forever. And if we do that, then if we have a lot more traffic or requests to create new URLs in the future, there will just be a higher risk of actual collisions. So, But
That's
yeah.
a great addition. Including the short URL, original URL, creation date, and expiration date in the database schema is essential. That expiration date will help with housekeeping and reduce the risk of collisions over time by allowing us to clean up expired entries. It also helps manage storage growth. That rounds out the core data model nicely.
Okay, so I think again for our functional requirement of analytics, I'm just gonna add um, a service. Again, it'll just take the shortening server and redirect service or both, and it will then just get analytics, so data on how stuff is being monitored. And I'll also add one to the cache because from there we can actually do some things. So for cache invalidation, again, we can't have the cache for a very long time. And the thing with shortening service is that if you have a cache, if you make a URL, chances are it's only really going to be popular for a short amount of time. So a very big concert venue might have a short URL, but it's not necessarily likely that they'll have that short URL for like a year or 2 years. It may just be a few weeks, if not a month. So we can have a cache invalidation for these larger events. I'm assuming something like it's a time-based system in my approach, and we'll have it be around 30 days. Does that sound good?
That makes sense. A time-based cache invalidation of around 30 days is a reasonable approach, especially for those high-traffic, short-lived URLs tied to events or campaigns. That way, the cache stays fresh, and you avoid stale data hanging around too long. It also aligns well with the expiration dates in the database. So yes, a 30-day time-based system for cache invalidation sounds like a solid strategy.
All right, so I think that's really it. Honestly, the trade-offs again, um, we are just having to mention the availability versus consistency, and um, for the actual workings of the scalability, the load balancers again, we're gonna have to put more focus on the actual redirection than the creation, but still there's going to be a high amount of traffic, so load balancing is very essential for this case, and that's also helping the high availability with not crashing the application and being able to have that low latency because we'll have um, server clusters to handle that load balancing as well.
Exactly. You've captured the key trade-offs well. Prioritizing availability and low latency, especially on the redirection side, is crucial. The load balancing layers ensure that no single server is overwhelmed, and that helps maintain both high availability and minimal latency. And as you pointed out, focusing more on scaling the redirection path while keeping the shortening path robust ensures overall system stability. This is a well thought out, scalable design.
All right. Well, thank you for inviting me for this interview, and hope to hear from you soon.
I appreciate your effort here. We've covered everything we need, and you did a solid job walking through the design. We'll be in touch. Take care.
All right. You too.